Cool. So hello, everyone. Welcome to WTF as an SVG. So a little bit about my background, because I feel like it kind of informs why I'm even really giving this talk. So I used to be a designer. I went to design school. I have a bachelor in fine arts. And so I have worked on both sides of giving developers SVGs and not knowing what exactly they were doing with them, and being the one importing SVGs and not knowing exactly what they were doing with them. So I've kind of seen both sides, and I've kind of seen how these get exported from design software, as well as how they're being used in Android Studio. So after talking to a few people and hearing that they literally had like no idea what these were and what they were supposed to use them for and like why they should use them, I decided to start looking into it more and got into this rabbit hole of looking at VectorDrawable source code for like hours. So I'm here to pass on that knowledge. So we have a few three-letter acronyms in this title here. The first one, I think you guys can figure out. If you don't know, like, ask your neighbor. But the second one, SVG, like what exactly is that? What does it mean? So the actual words that SVG stands for is Scalable Vector Graphic. And to kind of boil this down, because again, that's really doesn't mean anything if you don't really care about images or what graphics are or like anything. So scalable, basically the word scalable is you can scale it. You can scale it up and down, and you will not lose quality. You won't have that like weird pixelization from a raster image that's going to be kind of ugly and gross, and it's going to be very obvious that you scaled it up and down. Vector. So if you remember back to your like high school, middle school math classes, when you had like a grid and then you had to plot those things on a grid. So vector means we're drawing this graphic with vectors, and that's pretty cool because that means this is literally drawn with code. It's not something that we're saving out into a million little pixels that are all being used and being kind of floated around the internet. No, we're like actually drawing this with code. We're plotting these points on the graph. And then graphic, we're using this for images. You can use it for text. I wouldn't recommend it. That's because I took a typography class, and stretching type is a no-no. So basically, you can use it for other things, but let's stick to graphics. So I did mention raster. Again, you may not know what that means if you don't really spend too much time looking into images. Basically, for vector versus raster, vector is going to be line and curve based. It's going to be drawn with paths. It's going to be scalable. And so since we're not keeping track of a bunch of data of like where pixels are, what color they are, what opacity they are, our file size is typically going to be much smaller for these. And then raster is pixel-based. It's going to have measurements of DPI or PPI, basically meaning that we literally have this many pixels per inch, or as we come from the printing days, we were literally printing dots of ink on a piece of paper. And so you can kind of think of it in that way. If you draw really big dots of ink, you're going to have a like lower quality looking image. But if you print a lot of little tiny fine dots, you're going to have this beautiful work of art. It's great for images. That's one of the pitfalls of vectors is you can't really use it for bitmaps. Like you're not going to be recreating like the Mona Lisa with a vector. You could, but again, not really recommended. And since you have all that data, you're going to have typically larger files. So again, why should I care about vectors? This is why. Like if you try to scale that little search icon up and down and use it for different densities, if you try to use MDPI on like XXHDPI, this is what you're going to get is this top image. We don't want that. It's going to look gross. What we do want is to be able to scale our images so that we have this nice, crisp, clean icon no matter where we are, no matter how big we size it, no matter how small we size it. So when you open up an XML file, or an SVG file, this is what you're going to see if you open it up in a text editor. This honestly looks like garbage. It's just a bunch of numbers and letters, and it's crazy looking, and it's really hard to decipher unless you know what these things mean. So I'm going to go a little bit into what exactly all these commands are, so when you do get a vector image, you kind of know what to expect. So vectors mostly go off path data. So what, again, does that mean? So we're going to start off with our grid from high school, algebra, geometry, those nice little like plots that they had you like fill in, and like if you did all the equations, you'd get like a dog, and then you could color it in. It was really fun, and it was a lot better than doing like 20 like equations. So you thought this was awesome. So our first command we're going to start off with is M, which means move to. So if you think of this in drawing on a piece of paper, drawing on that algebra piece of paper, you're literally picking up your pencil and moving it to a spot. We haven't drawn anything. We're basically just saying this is where we're going to start. So in this case, we're moving to x coordinate 1 and y coordinate 22. Then we want to draw a line. So it's literally L means line to these coordinates, x, y. So we draw a line from our move to point to our line to. We can also use horizontal line in this case because we are just drawing a horizontal line, and in that case you can just tell it the one coordinate you want it to draw to. Since we're only moving on one axis, it's only going to have that one x coordinate. For the sake of really going in depth into this, I'm not going to use horizontal too much, basically just showing you the example that it does exist. But again, we have a line to. We can also use vertical, same basic principle. We're going up the y-axis, so we only need that one coordinate, and it tells the SVG, whatever it's drawing on, that we want that vertical line to be made. And then we keep drawing. So we have lines, lots of lines, even more lines, and then we want to close our path. So I think you guys can guess what we're making here. We have like a little house icon like for home. That's our typical iconography for like if you want to go back to the home screen. So Z basically says draw a point from wherever I'm at back to the beginning point. So wherever we start at M off, it's going to draw a point back to M. In this case, we're already at a like good ending point, so it's going to just draw that horizontal line down. This is something to keep in mind. If you call Z from like that rightmost corner, you're just going to get a line straight through whatever you're drawing, right back to the beginning. Don't pass go, don't collect $200, you're done. So curves. Curves are same basic principle, like we're doing everything on points. This is all vector based. So once you kind of understand that we're using vectors to draw points to each other, this is kind of the pattern we're going to be using. So in this case, we're doing a cubic Bezier curve. That basically means we have two little handles, and we're adjusting the curve based off those handles. So we have 3 points. We have the 2 control points, and then where we want to end our curve. Same thing here. So we're drawing a point at 12:14, a point at 15:16, and we're ending our curve at 15:17. And we're basically saying those are where we want our curve to be controlled. And so then you can go into a lot more. There's also arcs, which I'm not going to go into every single path data because we could be here for a very long time if I did that. But basically, the principle is we're drawing shapes here. You can also do very specific shapes. You can draw a rectangle, a circle. There's path data for all of those, and if you're more interested in those, it's very easy to find what exact path data you can use. We can also do things like fill. So we literally just provide it with a color that we want to fill, and if you use that endpoint, that Z, then it's going to tell SVG that we have a shape. We want that shape to be filled in with a particular color. If you just do fill on like an L shape, you're going to get this like weird diagonal line. It is technically filling the space that you have created, but using Z to close off your space is going to give it a lot better idea of what you want to fill. Stroke, we can specify stroke color here. So again, same basic principle, provide it with a color. It's going to change the color of the stroke on your SVG. Writing this kind of code is very, very tedious. And unless you're like some kind of savant, like I doubt that you're going to be able to visualize what points you're drawing and everything. You might get some kind of weird results. So there are software that will do this for you. Illustrator is Adobe's option for it. Inkscape is a free option, so if you just want to download that and start making SVGs without paying a cent, that's a great way to go. Or Sketch, which at this point is kind of turned into somewhat of the industry standard, and you can make SVGs in there as well. So this is the point where I tell you that literally everything I've told you up till now doesn't really matter because VectorDrawable is not a one-to-one example of SVG. So this might be the point where you like get up and walk out because you signed up for a talk on SVGs and you don't want any of this garbage and like bait and switch, like she's a witch, burner. So calm down, like this is how we're going to use SVGs in Android. Basically what VectorDrawable is it creates you a drawable based on XML vector graphic. So SVG is all XML based. I think all of us here are probably pretty familiar with XML. So it's going to create a drawable by reading that XML code. It's very similar to SVG, but as I'll mention later, there are some things that aren't included, and that's kind of where we fall into some of these areas that your SVGs may not look one-to-one. As Kelly mentioned this morning, you might have a lot of back and forth with your designer because you've got like points in weird directions and all sorts of craziness. This is why. It's based on XML vector graphic. It's not one-to-one to SVG. So VectorDrawable ultimately is XML code that's based on SVG. It doesn't actually read or support the SVG format. If you look at a VectorDrawable XML, it's going to have very familiar like Android tags on all of the data and everything rather than being just the straight up like fill, stroke, path, all of those things. As I mentioned before, I looked through a lot of the source code. What it appears to be doing is drawing the SVG on a canvas using that path data from the XML. So what it's spitting out to you is a drawable. And it also creates a bitmap cache to save on redrawing time just because, again, since the computer's literally drawing this graphic for you, if you have something that's very complicated, a lot more complicated than our house, then you can have some performance decrease just from drawing all of those points. So once again, that might be a reason why you don't want to recreate the Mona Lisa in a SVG. Something that's also great about VectorDrawable is if you use the compatibility version, it's going to save out pings for the lower versions. So VectorDrawable was introduced with Lollipop. Sadly, it does not support KitKat, but if you use compat version, it's going to basically save out all of those pings that you would have normally used anyways. So why should I use it? Like, if VectorDrawable is an SVG, if this isn't going to give me all the things that like SVG gathers, then like why should I use it? So you may have seen folders like this. Lots of folders like this. You might have like a whole downloads folder that's basically just all folders like this. And so once again, like if you need a new state, you get a folder like this. If you need a slightly bigger, smaller version, you're gonna get a folder like this. So again, scalable. That's one of those things. And not only scalable in the actual sense of like we're making the size bigger and smaller, like this is a lot more scalable in the fact that you don't have to go to your designer every single time you need something bigger or smaller, a different color or whatever, to provide you with another one of those folders. Space. So space is cool. Got a nice galaxy there, but while we don't exactly have a galaxy worth of space, this is going to save you space because, again, you don't have all those folders of all those different icons. You literally just have one drawable asset per icon. So if you have a lot of icons, if you have something that, like, you have a filter and it has 50 different categories and every category has a different color and, like, every category has a different icon, and then you need press states for those filters, and, like, yeah, that's going to multiply very quickly and it's going to get really big really fast. So this does allow you to save some of that space. Vectors, if you look at them, SVGs are usually in like the kilobyte range, not the like megabyte range. So again, you're not going to get like fantastic artwork out of these things, but like for most purposes, if you need a search icon, you don't need to have a ping for a search icon. You can use basic shapes to build out that icon. And then something that's really cool that they've introduced more recently is animation. So beforehand, you might have had to use something like a GIF or a video or something to do animations that weren't going to really scale well. Again, they weren't going to be super dynamic. They were basically just going to be pasting like a little thing in there. VectorDrawables do have the ability to be animated. So that's going to massively change. Like, you can do really cool things like the Twitter icon. When you like something, it does that nice little like spurt. So if you want to do things like the back to menu animation, that's really easy to do with VectorDrawable. I know they had an issue with that not necessarily being seen all the time, but if that's kind of the thing that you want to go for, it does give the user a little more impact. It gives the user a little more indication that something happened rather than just like changing the color or something. It makes everything feel a little more fun. So how do I make a VectorDrawable? So I'm going to go like way into each step of Android Studio's how do you import a VectorDrawable, assuming that like no one's done this before. If you have done this, then it's going to be really remedial, but like you may not have. Just curious, how many people are using SVGs? Okay, cool. That's really awesome. So again, here's your VectorDrawable code. You can technically write all of this by hand. No one's stopping you. I certainly wouldn't. If you have some time to kill, like a lot of time to kill, then you could do this. Again, it's just very Android-specific XML. You can see all of the general like path data, uses those commands that we learned earlier. Stroke line cap allows you to change the line cap of your stroke. Fill color, once again. The cool thing is you can go in and edit these things whenever you want. If you need a different color, it's very easy to just go in and change the fill color. So we're going to add our new vector asset. So if you just go to the wizard to create a new thing, we have all of our things there. Kotlin classes, this isn't Kotlin class, so we're not going to create that. So we're going to go to vector asset. And then you're going to get this little menu. So to kind of give you an indication of like what you're supposed to do here, they do preload a little Android icon. The really cool thing about this widget, if you're like very against using widgets and you just want to like drag and drop things in, they do have the material design icon library in here. So if you need something that's like the material design icons, back arrows, alarm arrows, literally everything you can get from here. So you don't have to go like Google material design icon library and download the SVG and import and everything. You can do it directly from here. So that's a cool thing to know for the next time that like your designer asks you to use just the basic alarm on icon. You can import it that way. But that's not what we're here to do. We're here to bring in our custom vector asset. So what we're going to do is click on local file. You can rename it whatever you want, house, home, whatever. Find the path on your computer to whatever lovely SVG you have access to. This next step is kind of important because it's very easy to overlook. It's something that a lot of people have mentioned, that like they get an asset that's like 19 by 22 from their designer, and then like it scales weird, and it's like weird, it's gross, I don't know, SVG is horrible, I'm never using it again. So this box automatically assumes you have a square, and it automatically assumes you have a 24 by 24 square. So if you do not check this box, and you have a long icon, like this little dachshund, your dachshund's going to turn into a bulldog. So if you do have a different size icon, if you aren't expecting something to be 24 by 24 DP, that is a very important box to check. It's going to save you a lot of problems, because then you won't get that squished thing and go back to your designer and be like, why did you give me a squished SVG? This next one, again, you can like use that to change opacity above. If you check this enable auto mirroring for right to left layout, that's going to enable you to automatically flip your icon whenever you use right to left layouts. It's a pretty cool feature. I don't know if anyone's like opened up a right to left layout. It's really interesting to see like the search icon goes in the different diagonal. So it's something that you might not really think about when you're just bringing in all of your icons. But if you do support right to left, I know that I've had a lot of experience having to do that. Then if you check this box, it's going to automatically flip that whenever you import it for right to left. Right now, we have a totally symmetrical icon. We don't care about that. So we're going to click next. And we're going to get, like, basically it's going to show us where in the file structure this shows. So we'll click finish. And then we have our house. Yay. So that's it. That's all you have to do. Then you have SVGs. You don't have to deal with those folders anymore. You don't have to deal with any of that. And animations. So once again, you can write animations by hand. It's slightly easier than like writing out like path data, but like it's still going to be a pain. So there's this really cool tool that's the shapeshifter.design tool. It's written by Alex Lockwood. He does have talks on how it works, how you can use it, all of those things. This is a very different talk if I go into that. So it's basically just going to, like, this is what it looks like. It's very easy GUI to kind of go through. You can even check if your SVG looks correct, because this is going to kind of set it on that canvas and show you what it looks like before you start importing it into Android Studio. So if you get some weird things in Android Studio, it's also kind of fun to import it here and see if you have any weirdness there. So you can do things like animate the path data, basically making the line travel around the strokes that you used. You can morph the path data, you can change opacity, all of those things. So I strongly recommend check it out if you are in the business of animating things. This is an example of my animation from the beginning of the talk. So that's the tool that I used to make it. It does offer an auto-morphing thing, so I believe he used gene sequencing software to do that. Again, if you are more interested, then like be super fun to go look at his talks for it. So basically, what we're interested in is exporting from this tool. You can export into SVG, VectorDrawable, animated VectorDrawable, and SVG sprite sheet. So you can use this more for more things than Android. SVG sprite sheet you can use for web animations. VectorDrawable, you can just export this as a VectorDrawable. So you can use this as an SVG to VectorDrawable conversion tool. But we're going to export it to animated vector drawable. This is what it spits out. I'm not going to spend too much time going into the exact stuff going on here because it's all generated by this tool. But basically, it does give you object animators. You can separate these out into separate files. And it works off interpolators, basic animation junk. So it's going to have all of that path data. It's going to export all this. You just bring it into your Drawable folder. So there are some possible problems that you may come across while you're doing SVG work. Performance is one of those. Again, if you try to create the Mona Lisa with an SVG, your app's going to have some problems because it's going to be trying to draw all of those vectors, and this is not going to go well, and you're going to have this situation, and nobody wants this situation in production. So a really great thing to realize is that a lot of those tools I mentioned earlier, Illustrator, Sketch, Inkscape, they all export a lot of garbage, like metadata, a lot of things that you don't need when you're exporting SVGs into VectorDrawable. So if you need to get rid of those things, just to cut down on size, then you can use these tools. SVGO is the GUI-less one. SVGO-OMG is SVGO's missing GUI. So you can go through, you can prettify the code so that you can better read it. You can remove metadata. I've had to use this in the past for very complicated SVGs that were being used for maps. Those can't be really simplified, but it is simpler to get rid of a lot of that extra garbage, and it does cut off sometimes a couple hundred kilobytes off your size, which if you really need that space, then this is a great tool to use. Cropping. So something that I didn't really go into depth on yet is when you export your import your SVG as a vector drawable, you're going to have this width and height and viewport width and viewport height. So something to realize is you can change these numbers. It's scalable. These aren't hard-coded forever. You can just change it, scale it up, doesn't matter. But the thing is you do want to keep that aspect ratio. If it's a square and you scale it up to 48 by 24, it's going to stretch. So this isn't just a magic tool to export and scale everything no matter how you want to scale it. So the important part here is the viewport width and viewport height. So what's that going to do? We're going to go back to our grid, go back to high school, middle school, whatever. Our point is starting 0, 0. We're going to draw our house again. It's going to be great. What viewport width and viewport height mean is it's basically telling Android and SVG, this is where my grid is, which is cool. We need to know where the edges of our grid are because otherwise our path data is meaningless garbage. But some pitfall that you can run into is when your designer is designing it, they have their artboard. Their artboard is considered the viewport width and viewport height. And so if they design their icon to be a lot smaller in that artboard, then when they export it, it's going to be small in that particular viewport width and viewport height. And so when you put it in your app and you start adding padding because you don't want it to touch the edges, because we're not barbarians, it's going to be small, and it's going to have this weird extra padding, and you're going to think you're crazy and continuously go in and remove padding and add padding, and it's just going to start moving all over your screen, and you don't know what's going on because where's this padding coming from? This padding's coming from the viewport. Same difference if your designer went crazy and scaled it up and then exported it and they didn't realize it was hanging off the artboard. Like, you're going to have this weird, like, cropping issue. Another thing is there's a thing that comes with SVG that's viewbox. If you move that viewbox around, it's basically a method you can use to crop. The problem is if you move that viewbox around and you like change it, it's gonna like crop edges off of stuff. So if you're having cropping issues or padding issues or anything like that, one great way, if you don't have Sketch, is to just go in and like open it in something like the shapeshifter tool or a different SVG converter. It will give you that kind of idea of like where it's sitting, and then you can either scale it yourself or ask your designer to cut the padding off. Basically, whatever you need to do to get rid of that extra padding. And then the really fun part of this talk is fill types. So SVG has this great thing that is a fill property. And when your designer gives you an asset, they could have this house with a little window, like we're making a little homey. And when you import it into Android Studio, your window's gone. Like, it's not homey anymore. Where'd the window go? Yeah. And then you like get angry at your designer and you're like, why did you give me this like faulty SVG? And like it's a whole conversation again. We don't want to have that conversation. We want to be nice. So what exactly is a fill rule? It's basically telling SVG that we have two fills on top of each other and we want you to deal with it in a certain way. Sketch has this great feature that you can just top different shapes on top of each other and then start cutting things out that way. And so when you get those assets that have the nice little homey window cut out, that's often the way that they're using that feature, is to cut shapes out. So when they give you something, if you put that homey little house on a blue background, the window looks cut out, you have a nice, super awesome, scalable vector drawable. The problem here that we have is Android and SVG use a different standard, or a different default than Sketch does. So we have two, technically three, but one is just default, inherit two fill rules, non-zero and even odd. So SVG and Android use non-zero. So what does this mean? So we're going to go back to our homey little house. And we're going to start looking at directions of paths. So basically what this means is all of our paths technically have a direction. They're going clockwise or counterclockwise. With non-zero, our paths are going to go clockwise and then counterclockwise to cut out that shape. So the fill rule is going to take our shape. It's going to draw a ray from the corner of the enclosed shape out in any direction. That any direction, SVG has a lot of stuff written into it that if it's not a valid direction, it'll just redraw a different ray. But essentially, we're going to draw this path through our shapes. And then we're going to count the points that we hit along those paths. So for non-zero, if it's counterclockwise, 1 is subtracted when we hit a counterclockwise path. And 1 is added when we go across a clockwise path. So in this case, the result is 0. Our inner path is outside of the house technically, and so we consider it gone. It's subtracted from our shape. In this case, it displays as empty. In the opposite case, if we use clockwise paths in both cases, we add 1. We add 1. The result is 2. In this case, it isn't 0, so we're not going to subtract those paths. We're going to consider it 2 paths on top of each other. And so in this case, you would use this if you want that window to be blue and you want the house to be black, and no matter what background you show it up on, that window's always blue. Sketch's default is even odd. So we're going to go through, we're going to draw our directions again. We're going to draw a ray. We're going to draw our points. And we're going to end up here. So regardless of direction, if we cross a path, we're going to add 1. And if we come out with an even result, we're going to cut out that inner path. If we come out with an odd, there's nothing in there, so we don't need to cut anything out. So the problem here is that the fill type is supported 24 and up. Not too many people that I know have a minimum SDK of 24. Sadly, as far as I know, Compat does not support fill types. So this can't be adjusted. You can't do anything about this in Android Studio. Sadly, what's going to happen is you're going to have to convert using a converter tool, which I have included a link to, that will correct the fill type. And so essentially what it's going to do is it's going to automatically find your inner path, reverse the path points so that it's going counterclockwise, and then it's going to have that non-zero fill type. Android's going to read it. It's going to cut your shape out. It's going to be great. Your house will be homey again. Another way that you can deal with this is you can talk to your designers. This might be a little bit harder to do just because it's something that's kind of complicated to explain to them. A lot of designers do not know all of this information about SVGs, so you're going to basically have to explain their fill types. It's a thing. Android won't let me change it. So I have included a link, but basically what's going to happen is Sketch does allow you to change the fill type. So they would have to convert it to non-zero. If they go in there and look at the fill type, it is going to display default as even odd. And then you're going to have to reverse those path points and anything that you want cut out so that it does end up coming out to that 0 and cutting out your shape. I've included a lot of resources on this particular topic because I know it's crazy and very in-depth. So what you can go do is fill rules. W3 has documentation on them. There's also an understanding fill rules. I have exporting SVGs from Sketch that you can literally send your designers if you need to explain to this very quickly. Like, I need you to change this SVG so that we have our shape cut out. And then Mark Allison also wrote a really great blog post on fill rules. It's actually where I found out how to do this because I ran into the same exact thing of I got a bug of the shape's not cut out. And I was like, what do you mean the shape's not cut out? And they're like, shape's not cut out. And I looked at it and shape wasn't cut out. So it was a very hard thing to track down. So hopefully you won't make the same mistake because, yeah, that was a fun couple days of trying to figure out why the shape was cut out. I kept looking at SVGs and, the shape wasn't, the shape was there. So, once again, you can go to all these. I'm going to tweet these slides out so you can actually click on the links. Another thing to expect when you're dealing with SVGs is just the thing we always have to run into and we always deal with is the API support for it. VectorDrawable was introduced with 21. There are a lot of things that they keep adding, like fill type. Fill type is 24 and up. Gradients they added in recently with 24 and up. So it is just something to keep in mind that you might have to tweak some things or deal with getting those pings for KitKat if you need to use it. Android does export automatically pings for KitKat if you use VectorDrawable Compat. Sometimes they might not be great for your purposes or you might find issues with them, so you might just have to add in that extra check for API level. Again, with gradients or fill type, just you can very easily research that. They have pretty good documentation on what they've added and what's available. So if you just go to the documentation for VectorDrawable, you can usually find out exactly what you can and can't do with it. So here's some more resources. The W3 documentation is really great if you really, really want to deep dive into SVGs. There's a lot more content that I wasn't able to cover because I only have 45 minutes and not like a week. So like that's your door into a whole new world. Also, if you're more curious about doing anything with SVGs, the web has done a lot with SVGs. Like their animations and features that they do with SVGs every day are like a great source of inspiration if you just want to see like what's out there, what's available, what exactly can you do with these things. So a lot of people will have basically their code written for web that has all of these features written in that you can kind of like dig through and find more about it. They've been doing a lot more animations a lot longer than we have, so there's a lot out there. There's also the Intro to SVG from W3 Schools, Mozilla Docs, and the Shapeshifter tool. Again, if you want to start animating, it's a really fun thing to kind of play around with. And so, again, if you have any questions, comments, rants about SVGs, you can tweet me at LauraJ_K. I'd definitely be interested in hearing more if you have anything to talk about. And you can find general contact info on laurajk.com. So thanks again for coming to the second to last talk and sitting through my rantings and ravings about SVGs.
It is now time for Q&A. Oh, wow, that's like, I think, the fastest I've seen hands go up all day. I'm going to start in the front, and we can work our way back.
Hi, excellent talk. I got two questions. First, what are the common tips and tricks that you can tell us, that we can tell to our designers if for any reason the SVG that they give us looks weird? And second, can you change either the fill color or the stroke color of an SVG by code on Android that you're aware of?
Yeah, so just general tips and tricks is, again, kind of that whole thing of like troubleshooting what your problem is. If you have like weird padding showing up, basically just like tell them to export with their paths touching the edge of the artboard. If you are having things not show up correctly, then changing that fill type. Just general things of like, SVGs should probably be fairly simple, definitely if they want you to recolor it. Kind of leads into the second thing, you can use tints to recolor. So that's a great way to kind of do it in just regular Android code if you want to start recoloring things. I'm not actually sure if you can go in and like modify the fill and stroke with code, so.
But at least with tint, you can kind of get away.
Yeah.
Okay.
Hi. One of the issues I've experienced while using SVG is that aspect ratio. So like in your case, in your example, if it is 24 by 24, that's fine. You can use wrap content, or you can give equal width and height. But sometimes some SVGs are longer, and like let's say 16 by 24. So did you come across any solution for managing the aspect ratio? Because if you give them wrap content, that may not work well, because in your layout, depending upon how much space they get for rendering, that aspect ratio may not work. Do you come across any solution for that?
So again, like if you use that wizard and you click the override, it will give you the ability to change those dimensions. And when you export it, if you have the dimensions 60 by 34, you're going to get a 60 by 34 vector drawable. The problem is if your SVG isn't 60 by 34 and you start like changing the aspect ratio of it, like if you're trying to make a like 24 by 24 into a 60 by 34, that's going to just stretch and distort, and you're going to run into issues.
any solution for that? Because most of the time, as a developer, we don't want to specify any specific number of pixels for width and height. We want to rely on available space. So if image gets squeezed, it will look bad based on whatever real estate it was able to get, on the screen size or rest of the components, whatever they left with, left that image. Do you have any idea? Like I had that issue for quite some time. What I end up doing is that I end up doing dimensions, custom dimension for each resolutions, which kind of leads me to the same situation we had where we had a lot of drawables. Now we have a lot of dimensions just to take care of that.
Yeah, basically, like vector drawables are going to be a specific shape, and you basically have to work with that shape unless you want to have multiple different drawables. In that case, then yeah, you could have a wider drawable that you use for landscape, or a square one that you use for mobile. Really, the only solution for that is to use different SVGs, because if you start stretching and distorting, it's going to start getting weird, unless you do start modifying that path data by hand.
So let's say we have one vector drawable that's used in multiple places, but just slight modifications, like different colors, maybe a different size. Is there any best practice on saying hey, is it better to have multiple vector drawables actually listed in your directory, or modifying them by code to make them having one black one and then changing the color by code in every use case that you need?
It's really up to what your personal preference is. If you want to have a black one, a white one, every color of the rainbow as a different drawable in your resource folder, then that's totally up to you. You can change all of those things programmatically as well. I know in my current use case of it, we're basically just using the different cases that we run into to tint it on whatever color we need. We start off with a black logo, and then if we need it for a dark screen, then we change it to white. So really, it's just up to your current workspace, your current personal preference.
Cool, thanks.
So for my own experience with vector graphics and a lot of the things we've seen in the talk, there are all these kinds of problems when you make a vector drawable from an SVG. So I was curious if you happen to know anything about the reasons why Android requires this extra step of the vector drawable and doesn't just have direct SVG support.
It really comes down to the fact that SVG is a standard of markup of XML. So it basically provides a standard for how the XML is crafted, how we're using this markup language, but ultimately markup language is just plain text. And so every system that you use it on, you're going to have some way to interpret it. You can technically import SVGs into Android and use them as such. From my experience, it doesn't come out so well sometimes. So VectorDrawable is really Android's answer to how exactly we're interpreting that XML data. And it really just comes down to they're doing the work for you of interpreting that path data and drawing it on a canvas so that you don't have to.
I was just going to answer the question with the color thing. I actually use themes. I have to have 10 different colors sometimes for my icons, so you can put doing it's in the tint color. You just do question mark, Android, and then color accent, or you can create a custom attribute and then just create colors that way, and you can call it whatever you want.
Yeah.
Also, and then in styles, you can set the color, I think, too. If you have different icons that you want them to have different colors. By doing that, and programmatically, like you said, with the background color and background tint. And I wanted to thank you, because the cutout part on the SVG problem, that was why I came to the class, because I looked all over the internet and I couldn't find out what was wrong. Because my Samsung devices were fine and they didn't care, but for some reason HTC and some of the other devices wouldn't show anything. So thank you, I appreciate it.
Awesome, thanks.